All right, now sizophendula this question 2 for this November 2023. In the description box, ngizoshiya ama-links for other questions that I've answered for this question paper. All right, so question 2, it's all about factor remainder theorem. There's also something about inverse functions, right? There's also something about inverse functions. All right, so it's 2.1, 2.2, 2.3. I'm just preparing you mentally what to expect. There's 2.4 and a last question 2.5. So it starts from 2.1 all the way up to 2.5. All right, now go 2.1. Maybe let's start here. Let's start here. Go 2.1. They have given us a function f, 12x cubed minus 28x squared minus 3x plus 7. They want us to prove that 2x minus 1 is a factor of f of x by applying what? The factor theorem. Long division is excluded, okay? It's a 2-mark question, right? So how do you prove that an expression is a factor of the given polynomial? So basipo f of x now, let me write it here. 12x cubed minus 28x squared minus 3x plus 7. Now prove that 2x minus 1 is a factor. We start off by equating this to 0 and making x the subject of the formula. So it's gonna be x equal to 1 over 2, right? Then we take the x. We are using factor theorem, right? So when you take the x and substituting it into the f function, you should get 0. You should get to 0. The answer, if you puma as 0, it means that the 2x minus 1 is a factor. However, if we substitute the x as 1 over 2 and then the answer doesn't come out as 0, it means that the 2x minus 1 is not a factor. Okay, so let's go ahead and calculate. So we are going back to the f function and substituting x, which is 1 over 2. Where there's x, I'm going to substitute a half. Cubed 28 a half squared minus 3, and then a half plus 7. Then you're going to punch in on the calculator. Let me do that. So it's 12 1 over 2. Okay, unfortunately you can't see the calculator on the screen right now. 1 over 2, but while I'm doing it, also do it. Take a calculator and calculate the value for this expression. So 1 over 2 plus 7. The answer is what? 0. So f of half gives us a 0. This answer that you get, it's the remainder. If the remainder is equal to 0, it means that this that you just substituted into the equation is your factor. So I have a remainder of 0. It means that I'm dealing with a factor here. Okay, 2.2. Okay, perhaps let me hide it instead of erasing. So 2.2, we are given the expression x cubed minus ax squared plus ax plus b. They are saying within now this expression, this cubic expression, is divisible by x plus 1, x minus 3, and x plus m. This means that these expressions or these binomials are factors of that expression. If they are divisible, they are what? Factors. So 2.2.1, determine the values of a and b. We want a value of a, we also want the value for b. So what is the best way to do that? Would be this, to say in this expression minus ax squared plus ax plus b. All right. So for the first factor, x plus 1, equate this to 0. When x is equal to minus 1, I should get 0, meaning that when I take this x as minus 1 and substituting into this expression, I should get 0, because the x plus 1, x minus 3, the x plus m, they are factors, they are divisible through that expression. So when I substitute minus 1 on every x value, on every x variable, minus 1 plus b, I should get to 0. So it's minus 1, minus a, and a plus b equal to 0. So we're going to have a minus 1 minus 2a plus b equal to 0. Transpose the 1. Should we? I don't know. But you know what? How about we say, we write it like this. City b equal to positive 2a plus 1. And call this equation 1. We have no other choice. Remember, we are calculating a, not b, right? Now, after substituting the first factor, we discover that we have two unknowns, a, not b. So in order to get the a and b, we'll end up with a simultaneous equation. So we're going to substitute the next factor, x minus 3. X minus 3 equal to 0. Make x the subject. It's 3. It's positive 3. Going back to this expression and substituting with 3 this time. Cubed, squared, 3 plus b. This also should give me a 0, because that is a factor. So it's 27, but let me verify. 3 raised to exponent 3 should be a 27, minus 9a plus 3a plus b equal to 0. Okay, equal to 0. Now I also have like terms on this one, this 9 and that 3, 6, 7, 8, 9. Okay, it's minus 27 minus 6a plus b equal to 0. Again, let's make b the subject. Even on this one, b is now gonna be plus 6a minus 27, equation number 2. Then we take the first equation and equate it to the second equation. We now have a 2a plus 1 equal to 6a minus 27. Bring the 6 over the side. About 2a minus 6a equal to minus 27 minus 1 minus 4a minus 28, dividing by minus 4 minus 4. We find that a is a is equal to 28 over 4 is 7. We find that a is 7, and then let's also get the value for b. So it's either you use the first or the second equation. I'm going to use the first equation. I'm going to say b is equal to 2, where there's a in Fabu 7 plus 1, 15. b is equal to 15. This is our final answer. Then on the next question, 2.2.2, determine the value of m. I have b as 15, I have a as 7. I also have a as 7, 15. This is 7, this is 7, okay? This is 7. Let me hide this again. So determining the value for m, finding the value for m. Let me show you something with this. Back. The x plus 1, when multiplied by x minus 3, multiplied by x plus m, right? It should be equal to x cubed minus ax squared plus ax plus b. How do I know this? I know this because we are told ukuthi these vectors are divisible through this, right? I'm a factor, so when multiplied, they should give me back the original equation, okay? So let's try foiling out this. Lana kuyoba x squared. Okay, let's foil the first two brackets. So kuyoba x squared minus 2x minus 3. So after foiling and getting like terms in the middle, you'll end up with something like this. And then x plus m is equal to x cubed. Nothing happens on the right hand side. So I'm going to keep writing it as it is. Now let's foil the last two brackets. We're going to have an x cubed and plus mx squared and minus 2x squared and a minus 2mx, and then let's multiply with the last one. The minus 3 gives us a minus 3x and the minus 3m equal to, okay, the x cubed minus ax squared plus ax plus b. Now check this out. This cubed corresponds with that one. The x squareds corresponds with this. The x variables, they correspond with that, right? And then the 3m is a constant, right? Is a constant b. So this means that the minus 3m should be equal to b, right? It should be equal to b. But then we calculated the value of b to be what? To be 15. But I'm putting x la. So it's minus 3m equal to 15. Then we're going to divide both sides by minus 3. And find that to m it's actually minus 5. So this is our m value. Let's go for 2.3. Let's take this down. Now since our 2.3, so this is where let me just say it's a section on our inverse functions. So from 2.3, 2.4, 2.5, it's all about our inverse functions. Now given the set of ordered pairs, right? So instead of giving us a actual graph or a table of some sort, basipa ama ordered pairs, right? Ama ordered pairs, it's just a set of coordinates. I mean a set of points with the x and y coordinate. So this is point number, let me use mhlambi yellow. This is point number 1, point number 2, point number 3, and point number 4. 4 ordered pairs are given. So 2.3.1, write f minus 1 as a set of ordered pairs. So this is f minus 1 is the inverse function. So f minus 1 with the associated ordered pairs, it's gonna be this. It's gonna be this. Let me just write the points empty for now. Alright, so this is what we have. Now the original function has minus 3 as the x value and 5 as the y value. So the inverse function is going to be a 5 and minus 3. Second point, x is minus 2, y is 5. New ordered pair for the inverse function is going to be a 5 and minus 2. Next one, it's 0 and 7. So the ordered pair for the inverse, it's going to be a 7 and 0. For the last one, it's going to be 9 and 2. What actually happened, Lauguti, we just took the x and y values and swapped them, right? Because when dealing with our inverse functions, that's what you normally do. You swap the x and y coordinates to get the inverse function. All right, so this is the new ordered pairs, right? Now for the next question, they are asking us if this is a function or a non-function. Now, pay attention to the following. Pay attention to the following. So this x, this x, this x, this x, but particularly these x values. These x values are producing different y values. A relation is considered a function. A relation is considered a function if ama x values wako they are mapping to the, okay, like in this case, this is x u5, this is x u5 as well, right? If these if this 5 and this 5, they were mapping to the same y value, then this whole thing was going to be considered a function, né? But now it's not going to be considered a function because the repeated x values are not mapping to the same y value. They are mapping to a different y values. So this one, this 5 maps to a -3. This 5 maps to a -2. If they are mapped to the same coordinate, then we're gonna refer to this thing as a function. But in this case, it's a non-function. It's a non-function. Now with 2.3.3, write down the x-intercept of f prime. So x-intercept, it's x equal to 7. This is the x-intercept, 7 and 0. So when x is equal to 7, that's where the x-intercept is found. Now go 2.3.4, write down the domain of, okay, this is an interesting question. Go 2.3.4, write down the domain of f minus 1. Okay. All right. Okay. Check ala. Pay attention. Pay attention. What is the domain? The domain is the set of all x values that are part of forming part of the function. So now my x value swami 5, 7, 9. This is the lowest value. This is the highest value. So between 5 and 9 is my domain. So it starts from 5, it ends at 9, and everything in between 5 to 9 is considered a domain for this function. So the domain, Lana, it's gonna be x element. A domain is all, the domain is what? It's the set of all possible x values. So in this order, in these ordered pairs for the inverse function, it starts from -5 to 9. But the 5 and the 9 are included. So I'm going to use a square bracket. So it's going to be x element of 5 and 9. Or like this. X element of... no. I'm going to use this notation. Oh, the end statement. So it's going to be a 5 less than or equal to and less than or, did I say end? It's x la. It's x, not end. It's between 5 and 9. We can write it like this as well. All right. So this is 2.3 for us. Let's check out 2.4. Let me hide 2.4. So here's 2.4. Okay, another interesting question. Very interesting question. Just some adjustments there. Okay, so the graph below represents the following function with the general equation given g of x or y is equal to 2x plus 4 with the domain Now the domain is quoted in set builder notation. Do you see that? It's quoted as a set builder notation. So this is the domain. It starts where? Let me use black for now. Yeah, black. So this is black. It starts where? Go minus 4 and then ends where? With 2. So right here we actually have a 2. We have a 2. Now let's map out lama values now, meaning that let's get the corresponding y value for the x values. So in this equation, where there's x, I'm going to substitute to minus 4, get the answer, and substitute to 2 and get the answer as well. So 2 open bracket minus 4 close bracket plus 4. I'm getting a minus 4. I'm getting a minus 4, right? Getting a minus 4. So for 2, I'm thinking 8. Yeah, it's 8. 8. So the corresponding y value for 2 ubani 8. Okay. Not that they are asking for it, but I mean, I'm just saying, let's have, it would be convenient for us to also have y values, the corresponding y values for the x values. All right, now 2.4.1, 2.4.1, yes. Determine the equation of g or g minus 1 of x in the form y equal to. Okay, so this is the original function. G of x is equal to 2x plus 4. Now this translates to a y equal to 2x plus 4. Swap, then we swap this to that and this to that. We now have an x that is equal to 2y plus 4. And then this is our g minus. This is our g minus. We now have the inverse function. But the next task would be to make y the subject of the formula. So bring 4 over this side. Over minus 4, x minus 4 equal to 2y. Divided by 2, divided by 2. Then you eventually find that y is equal to x minus 4 over 2. So this is what we have as our y, as our equation for the inverse function. Now 4.2.4.2, analyze the graph and write down the domain of this. Okay, analyze the graph. All right. Okay. Now here's a question. I want you to think about this. I want you to give this some thought. Lapha 2.4.2. This is the domain for the original function, right? So the inverse function, I just want to tell her the inverse function. What do? You swap x no y, right? So the same thing applies with the domain and range. Your domain is gonna be the range of the inverse function, and the range of the original function will now become the domain of the inverse function. So it means that, back, I understand they want the domain, but let's get both the range and domain for the inverse function. But let us start with the range. Yeah, let's start with the range, not the domain. Let's start with the range. I want to show you something. So now the range of the inverse function is gonna be, I understand they want what? The domain, but how about just as an extra thing to do? Let's also get the range for this. Né? Now the range for the inverse function would be, we're gonna take this domain and just replace x no y, replace x no y, replace x no y. So it means that the range for the inverse function is gonna be y minus 4 less than or equal to x less than 2 okay, back on fabu x, like it should be y, and then y element of real numbers. So this is the range of the inverse function. Ne? This is the range. All right, now it means that in order to get its domain for the inverse function, you would need the range for the original function. Let's also get the range for the original function. So usakhumbula, on the first thing we did what? We calculated the y values. Yeah, one. I was actually preparing for the last question. Now, the range for the original function is this. The range starts from la, and so we look at the y values. So the y values are starting with minus 4, going all the way up to positive 8. So it means that the range, it's gonna be minus 4 less than or equal to y, and the y even less than 8. Ne? 8. The 8 we exclude because of there's an opening in the circle. It means that that value is not included, but there's a jump or a break in the there's a break at the end point of this function. Right here, there's a break. An open circle means break. Do not include that value. A shaded circle means that it's included. So the 4 is included, but the 8 is excluded. All right. So this is the range for the original function. This means that its domain, we are now answering the question. The domain, it's gonna be x minus 4 less than or equal to x less than 8, where x is element of real numbers. So what happened, or how I got to this, is that I took the range of the original function. This is the range for the original function, and converted it into its domain for the inverse function. So this is how you deal with the domain of our inverse functions. So just a quick recap. So this is the domain for the original function, right? So in the inverse function, this domain becomes a range, and then the range for the original function will be the domain of the inverse function, right? So ngithethe this thing exactly as it is. I just changed y and made it x. That's it. Okay, so last question now. 2.5. All right, we are given h of x, that is equal to a minus 4x squared, where x is element of minus 2 to 0. So lana ke, that x element of minus 2 to 0 is the domain. So it means that this function is not plotted it's a restriction. That x element of minus 2 to 0, it's a restriction. The function is not sketched fully, but it's restricted in a bounds in a way, right? So in this instant, reading this function would go something like the 2 on our function is excluded, but the 0 is included. So it starts at the origin, it ends somewhere with minus 2, but the negative 2 is not going to be included. So for 2.5.1, determining the equation for the inverse. Let's find the equation for the inverse. So this is h of x, x squared, converting this to a y, swapping our variables. We're gonna have an x equal to minus 4 y squared, and dividing both sides by 1, minus 4 cancel, we now have x over minus 4 equal to y squared, and taking the square root on both sides. And taking the square root on both sides, it's gonna be what? It's gonna be y, that is equal to the square root of x over minus 4 over minus 4. So this is the inverse function. All right, this is the inverse function, the h of x minus 1 is the inverse function. Now 2.5.2, okay, I think this is an interesting question, but yeah, okay, no buts. So tola a point of intersection. How do you get a point of intersection? A point of intersection, it's where both it's where two graphs meet, they intersect, meaning that it's where you have two graphs that are equal. Point of intersection, you take your functions and equating them and solving for x. So h of x is going to be equal to an h of minus 1 x. Okay, all right, now this is equal to what? Minus 4x squared equal to the inverse function. We just calculated it to be this. It's what? The square root of x over minus 4. Then on both sides I'm gonna square. I'm gonna remove the side by squaring both sides. So we're gonna have a positive 16x raised to exponent 4 equal to an x over minus 4. So this cancels this. And then cross multiplying, dividing by 1 on this side and multiplying. So after doing this cross multiplication, what are we getting? 16 times 4. 16 times 4 is 64 minus 64 x exponent 4 is equal to x Now from this point, how do I solve for x now? How do I solve for x? Okay, the next step would be to say 64x exponent 4 minus x is equal to 0, and make all this x, taking out x as a common factor. But let me take out minus x as a common factor. Then sala a 64x raised to exponent 3 minus 1 equal to 0. So the first x is going to be equal to 0. It's minus x anyway, equal to 0. Then simplifying further, it's x equal to 0. That's the first x value. And then what's the next one again? We take this 64x cubed minus 1 equal to 0 and doing the following. 64x cubed is equal to 1, and dividing both sides by 64, you now have an x cubed, that is 1 over 64, and taking the cube root on both sides, x now becomes, what is the cube root? Shift 1 over 64. I'm thinking 4, but I want to verify. Yeah, it is 1 over 4. It's 1 over 4. It's gonna be 1 over 4. Alright, so the next x is what? It's x 1 over 4. Okay, I'm a little worried because x is element of minus 2 to 0 included. This is our domain. There it is. That's our domain. That's our domain. But instead of having a negative x, I'm having a positive x value. Right? That is concerning, but it's something that we shouldn't worry about, né? Because of this cube root. So what I'm gonna do I'm gonna continue with this calculation and say, okay, hey, listen up. We can use either this equation or that equation to get the y value, right? So we have calculated the point of intersection. The first x is this, and the next x is this. So there's 2 points of intersection. So let's get the y value for the first point of intersection. So I'm gonna say y is equal to, I'm using this equation, minus 4x squared. I'm using h of x, so it's gonna be a minus 4, where there's x and further 0, y is equal to 0. So the first point of intersection is 0 and 0. And then the next one, I'm still saying it, this is concerning, but it's something we shouldn't worry about, right? Because we can actually put in a negative value over this. We can put in a negative value over this one. Okay, I feel like I feel like I'm hijacking this thing. Let's back up. Okay, let's back up a little bit. Let's just back up a little bit. I want you to gain insight. When inside, I want you to understand. I'm not in a rush. So I want to create understanding here, not to rush the question. So meaning that, was that necessary? Me erasing the whole thing? Yeah, okay. Let's come back here. So y to 2.5.1. So y is equal to a plus minus the square root of x over minus 4. X over a minus 4. All right, x over a minus 4. Okay, but now we should be working with what? Y as equal to a minus square root x over minus 4. All right, why? It's because of we are working on the domain of minus 2 and 0. So it means that is this y? Yeah, the y should be negative. It shouldn't be a positive. It should always be a positive, no matter what, because under this domain, you'll see once we start sketching, it will make sense. But for now, just play along. We're gonna need to use the negative one, right? We're gonna need to use the negative one. So going back to 2.5.2, let's go back and calculate the point of intersection. H minus 1x is equal to, so h of x minus 4x squared equal to minus square root of x over minus 4. Okay, so this negative and this negative, they divide each other and give us a positive, equal to square root of x over minus 4. Actually, I'm going back to where we started. So multiply, going back. You know what? We calculated this and ended up with x equal to 0, y equal to 0. Now, the last part was this, us getting the y value for x equal to minus 1 over 4. So the final answer was positive 1 over 4, but I'm making it a negative. I am allowed to do this if we are dealing with a cube root. When we are dealing with a cube root, I'm making x to be negative because of the domain, right? Because of the domain. If x becomes positive, it won't make sense. It wouldn't make sense. Yeah, no, this was a loaded question. Okay. Anyway, so x is equal to that. Let's get y. So now y is equal to, so we are going to use 4x squared. Interesting. Okay. Interesting. Equal to 4 over, okay, I don't want to explain too much. but either equation, whether you use this one or that one, this one, it doesn't matter. Y is equal to minus square root of x over minus 4. Y is equal to minus the square root of x, which is minus 1 over 4 over minus 4. So Lana, the answer is gonna be y equal to minus over, what is negative 1 over 4, 1 over 4 divided by negative 1 over 4, so that's 16, 1 over 16. So this negative divided by this negative is positive. Square root of 1 over 16. Y is equal to minus 1 over 4. Therefore, another point, the first point was 0 and 0. Next one is minus 1 over 4 and minus 1 over 4. Alright, so these are the points of intersections. Now, let's hide and open up this one, because we want to draw a neat graph of both this and this on the same system of axes on the answer sheet. Clearly show the line about which this reflects this and label it, and show at least one point on the line of symmetry and at least one line on the line of symmetry. Okay, no, I must admit this question, yeah, no. All right, so it's this, so it should go something like this. This. Okay, this is not the graph, but the symmetry line about which the reflection took place. Alright, so this is the line y equal to x. Now, maybe let's start with the points of intersections, 0 and 0. Right? Then it's equal to minus 1 over 4, which is 0.25. Negative 0.25 somewhere. So, okay, before we even continue, let me show you what this domain thing is all about. The graph is so you draw. The graph we're gonna draw is over this domain. So it starts at 0 and ends go minus 2. Right here go minus 2. Okay, where x is element of minus 2 all the way up to 0. Okay, yeah. So it doesn't go from 0 to the positive side. Hence I'm saying we do x work should be negative and your y should also be negative. Alright, then we can perhaps start off by plotting h of x, but before we do that, I shall plot the graph, clearly show the line about and show at least one point on the symmetry line, okay, which is that 0 and 0. Alright, so minus 4x squared, I'm gonna plot 2 points la so lana I'm gonna substitute this minus 2, minus 4 minus 2 squared. So minus 2 squared, that gives me 4, positive 4 times negative 4, that's negative 16. So I have a point minus 2 and minus 16. So minus 2 and minus 16 right here. But we're gonna have to exclude this one. Say exclude a circle like this, an unshaded circle, because it's minus 2 excluded. So since this is a parabola, I can see it by the x squared. So we're gonna connect everything up like this and create a parabola. So this is the point minus 2 and minus 16. Alright, so let me use maybe red to plot the inverse here corner. So we take this point and flip it like swap my coordinates corner like this. So it gives me what now? Oh, minus 16 and 2. Minus 16 and 2. It's this one. I'm shading a second, by the way. It's gonna be this. And then it starts at the origin and then ends at something like this. So this is minus 16 and minus 2. Alright, but in my opinion, I sort of feel like the 3 is unfair. It's kind of unfair. Yeah, anyway, this is the function that you should have drawn for this question. So check out the description box for more content that I've created for this question paper. I hope we enjoyed it. I hope you got something out of this discussion. I'll spawn on the next recording. I'll see you next time. Bye bye.